Alright, welcome to this video where we are going to learn about energy and how the energy of a photon can be absorbed by electrons. And those electrons can actually jump to higher energy levels than they should. Let's go ahead and review electron configuration real quick and the concept of it. In an electron configuration, what we're doing is we're showing the location of the electrons. Now, according to the off-ball principle, lower energy levels will fill before higher energy levels. And so, when we're looking at electron configuration, we fill in the electrons based off of lower energy to higher energy. However, electrons can actually absorb energy from heat or light and jump to higher energy levels than they should. And so atoms will be able to exist in two states in relations to energy. The first state is the lowest energy state of an atom, and it is called the ground state. And so the ground state of an atom is the lowest energy possible that the electrons can be in. And so your normal electron configuration will show the ground state electron configuration. Now, again, I want to just say this again. Ground state electron configuration is the normal electron configuration that we have gone over so far in class. Now, a state in which an atom has a higher potential energy is called an excited state. And an excited state will occur when an electron absorbs energy, usually from either heat or light, and will jump up to a higher energy level. And so when it absorbs that energy, it jumps to that higher energy level, and we say it's in an excited state. Now this here is a really great example of how an electron will absorb energy, jump to a higher energy level. So if you take a look at the atom on the left, you'll see that it's on the first energy level right there. And what will happen is it'll absorb energy and jump to that higher energy level. Now notice that whatever goes up must come down, and so when it comes down, it is actually losing energy, and it loses that energy in the form of light. And so notice again, we're going to watch it's going to jump, it's going to absorb energy, jump to a higher energy level, and then it will fall, giving off energy. Now notice how it gives off in the form of light, and that photon of light in this particular example is going off and hitting another electron in another atom. And again, that electron gets excited and then falls down. Now electrons can move to higher energy orbitals by gaining a specific amount of energy or a quantum of energy. And so let's go ahead and take a look, think about these energy levels here. For an electron to go from here to here, it has to gain a specific amount of energy. If it's not going to gain enough energy, let's say a photon of light comes in and the photon of light is not enough energy to bring it to the next energy level, it will not absorb that photon of light. Now, when electrons fall back from their excited state, what will happen is they will release a certain amount of energy. They'll release a quantum of energy. And so again, the amount that they fall will be the amount that it releases. And so a great illustration of this would be if we think about a ball on some stairs. If we have a ball on some stairs and we were to take the ball and move the ball to the next step, you can either go from the first step to the second step, but you can't go to in the middle. So it's either got to be on the first or the second. It can't be in the middle. And so it's got to be the exact amount. Now, something else we want to think about is we can take the ball and go from the first step and go all the way to the fourth step. Now, when it comes back down, it can do a couple things. It can go all the way from the fourth to the first, and when it does that, it'll give off all of that energy in the form of a photon. Or it can actually hit multiple steps on the way down, giving off multiple photons of energy. And so again, it can either go all the way down, giving off one large photon of energy, or it can hit multiple steps on the way down, giving off multiple photons of energy. And because they have different energy, we actually see them as different colors. So let's go ahead and take a look at this right here. We actually saw this energy diagram on the very first day of this unit, and we haven't talked about it since then, but we're going to talk about it now. Notice how the very bottom of the graph here, or the very bottom of the diagram, it says n equals 1. That means it's the first energy level. Notice how when we go from the first energy level to the second energy level, notice how there's a big increase in energy. Notice though, when we go from the second to the third, there is a large increase in energy, but it's not as large as going from the first to the second. And in fact, as you go up, the amount of energy that is gained is reduced each time. But let me say that again. The amount that is gained is reduced each time, but it's still increasing. So for example, the sixth energy level has a greater amount of energy than the second, and it has a greater amount of energy than the first. But going from the fifth to the sixth is not as great of a difference as going from the first to the second. And so it's the difference in energy that's important. So if we were to think about an electron falling from the second energy level to the first versus an electron going from the sixth to the fifth, the one that goes from the second to the first is going to give off a higher energy wave. The one going from the sixth to the fifth is going to give off a smaller energy wave. And so you will need to know this. You do need to understand that as we go up in energy, the amount of energy that it increases gets smaller. And so because there's a smaller difference in energy, that means that if an electron goes between those two levels, it's going to be a smaller, it's going to be a photon with a smaller amount of energy. And so this diagram shows you how if you go from the second energy level to the first, or you go from one energy level to another, that difference in energy is going to be equal to the energy of the photon that's given off. Now, the emission spectrum of an element will actually show you the different colors of light that an element gives off. In other words, the emission spectrum of an element will show you the different energies of photons that are given off. And every element is going to give off different energies when its electrons go from an excited state to a ground state. And the reason why that is because each element has a different electron configuration. And when you get all these different electrons in there, all the electrons can do a different combination of things. And so let's go and take a look at an example of an emission spectrum. These are examples of emission spectrum. Notice how hydrogen gives off a purple, a blue, a green, and a red. And when this occurs, what ends up happening is we actually see all of those colors together as one color. Now, helium gives off those particular colors. Neon gives off a lot of reds and yellows. And so notice how there's different colors that are given off, or a different combination of colors that are given off by each element. And so when we see these elements go from an excited state to a ground state, they actually give off different colors. A great example of this is fireworks. When fireworks go off in the air, you can actually see the different colors because there's different elements within those fireworks giving off those different colors. Now, a really great example of where we use this is actually in identifying the substances that are in stars. And so when we look at the light that's coming in from a star, we can actually separate that light and see the different spectrum or the different energies that are given off. And we can determine what elements are within a star. It's pretty interesting stuff. If you want to take astronomy, we have a really great astronomy teacher here at Round Rock High School. And that's it. Go ahead and do those independent practice problems. The answer key will be on my website. And if you have any questions, feel free to email me. Have a great day.